All right, welcome to part 2 of the video series about our first day of school brain teasers or or problems. And we're now on problem number 3, which has to do with pigs and chickens. And she counted their heads and legs. I don't know why she didn't bother counting the chickens themselves. But nonetheless, the problem goes, she has 70 heads and 200 legs. How many of them are pigs and how many of them are chickens? So the problem itself, it's not that difficult really, but one of the things that you can do is you can start by organizing a table just to see how things go. For example, you just guess, hey, what if there's 10 pigs? Well, we need 70 heads, which means we need 60 chickens. So in other words, these two numbers have to add together to give me 70 heads. As far as legs are concerned, we'll have double the number of chicken legs for heads. So in other words, every chicken head has 2 legs to go with it, hopefully, and every pig head has 4 legs to go with it. So we have 4 legs times the number of pigs and 2 legs times the number of chickens for a grand total of 160 legs. That's not enough. What was said was, if I remember, just 200 legs and 70 heads. So we're going to have to look for another one. So we can keep looking until we get numbers that add up to 70, and then go back over here and quadruple the number of pigs to get the legs and double the number of chickens to get the legs and tally that up. Here now again we're at 170, which is again a little bit shorter, so we can keep on going and going and going. I wrote 2040, that should be 2050. Nice. Alright, sorry, I'm just doing a little quick edit. Okay, so moving on, if I was to complete this table in its entirety, I would actually see that if there were 30 pigs and 40 chickens, that's 70 heads and a total of 200 legs. So your solution is right here. I didn't need to go through and complete the whole table, but I was able to stumble upon the correct solution here. Now, if the solution were not so simple, like 30 and 40, what if it was something like 37 and you know, whatever, 32 and 33, whatever. I don't think this table method would be super effective. In fact, it wouldn't be that efficient at all, which is why we have algebra. So with algebra, we can express the sum of the pigs and chickens to figure out how many heads there are as pigs plus chickens equals 70. The number of pigs plus the number of chickens is 70. And here we can say 4 times the number of pigs to get legs plus 2 times the number of chickens to get legs gives us a total of 200 legs. So this is what's called a linear system. And if we have the ability to use math language to translate into math equations, just like the first problem with Mimi, we can actually do algebra. And we'll talk about this more this year, but some of you should have seen that in Algebra 1. Nonetheless, I was able to do a substitution to find the value of p for the number of pigs, and then you do another substitution to find the number of chickens. So finally, though, I would like to demonstrate that the equation pigs plus chickens equals 70 can actually be graphed. And what you have in the red line here is every situation where there are 70 pigs and chickens total. So there could be 70 pigs and no chickens, or there could be 70 chickens and no pigs, or anything in between. The blue line represents where there's 200 legs. So you could get 200 legs by having a total of 50 pigs, or you could have 200 legs by having a total of 100 chickens. Or anywhere else on this line, if there's a few more pigs and a few less chickens, then we'll have a different scenario. So these are all the ways we can have 200 legs, and these are all the ways that we can have 70 heads. But there's only one place in common. That is that there's 40 chickens and 30 pigs. It's the only way to have 70 animals with a total of 200 legs. So there's only one solution, what the graph shows. My reason for showing you this problem is to illustrate how mathematics can be, you can utilize more than one tool. For example, we have now this mathematical table as a way to organize our data, and by organizing our data we could sometimes find what we're looking for. Some people tend to be proponents of algebra. If you're able to write English in terms of mathematics, you can apply the algebra, and it turns out to be relatively easy to do, easier than just guessing and checking. And finally, you can represent the same situation as a graph, and if you did, you would have a deeper understanding of the whole situation and a very clear support for the work that you did with your algebra. I guess what I'm trying to tell you is that when we do problem solving and when we study mathematics, it's not just about the answer that we're looking for. It's about the process we choose. Is it efficient or inefficient? And it's also about the support. Does one process give us the same result as the other? If I use my table, if I use my equations, if I use my graph, I always get the same result. So there should be no contesting my results here. So that's the purpose of that particular problem. Just as a quick reminder, we've talked about this one with the boys and the bikes and the fly. But remember that what we learned from this particular problem is that in order for the bikes to crash, they have to ride for an hour. If the fly flies for 1 hour, it will fly 15 miles because that's how fast it was flying. But I also learned that, so what I learned from this particular problem is that sometimes the answer could be right in front of you, and if you don't have your awareness of what the problem is asking for, you might miss it. You might overcomplicate things. But the other thing that came out of this was this interesting idea of infinity, because if you thought about it long enough, you'd recognize that theoretically speaking, this fly is never going to stop moving because it's always going to go a small fraction of the distance between each part. It's hard to understand how you can always have infinite different transitions for the fly and still have a total distance being finite or fixed at 15 miles. But if you think about it as a box, this box represents 15 miles, and the fly covered about 80% of that 15 miles in the first stage. In the next stage, it covers a small fraction or a large fraction of the remainder. So here's more distance that the fly traveled, and then another fraction of the remainder, so there's even more distance. And then we could take this and color it in even more, and then we could take that remaining square and color it in even more, and we could take the remaining square and color it in even more. And so what you'll see here is that we keep getting smaller and smaller and smaller chunks of space, but eventually we'll be limited by the total 15 kilometers or miles or whatever. So I guess what I'm trying to say there is a lot of times you can learn more about mathematics and learn more about life after you've answered the question. I've answered the question, but I've revealed something about infinity and finite and all sorts of weird stuff. I'm not expecting all of you to be totally getting what I'm saying here, except to say, don't just stop because you have an answer. Spend some time thinking before you move on. So there are other problems, and I'm not going to include them in the video series because I don't want this to go on any longer than it has. But just very briefly, I'll just show you the solutions. So for this one with the balls in the earth, all we had to do was recognize the formula for circumference. It can be changed by the radius. And so if the radius happened to be 5 units, then 10 pi would represent the circumference. Well, we don't even have to know the radius to be able to talk about the circumference. We can describe it in terms of our new radius. So what if the radius of the Earth plus 1 inch we called r plus 1, then the circumference is 2 pi times r plus 1. There's a distributive property, and this is the circumference of the Earth. This is the circumference of the Earth with an extra inch added to the radius. If you take the big circumference and you subtract the small circumference, you'll have the extra amount of rope needed. Turns out the extra amount of rope needed is 2 pi, which is about 6 1/4 inches. So whether we add an inch to the soccer ball's radius or we add an inch to the Earth's radius, it doesn't matter. We'll only need 6.28 inches more. In other words, this turns out to be a line. The circumference and the radius make a linear relationship. Now you studied that last year in Algebra 1 with y equals mx plus b, but you didn't notice that this happened to be a linear situation. Why? Because it didn't say anything about y equals mx plus b. It said things about radii and circumferences and all this other stuff. So the issue here is you can learn about linear functions, but it doesn't mean anything if you don't know when you're supposed to use what you learned about linears. And if you don't understand what a linear function is, even though you studied it, then you might be wasting your time. So anyway, I said I'd be quick. This water tank one we'll talk about in class. That one has, the main lesson there is to be talking about rates. And rates are fundamentally important to the study of mathematics. And then we have the cylinder, and that one is just sort of a teaser question. Think about that one. If you unravel it, the cylinder with the string wrapped around it, you would get 5 right triangles. And if you remember the Pythagorean theorem, you can find that the string represents 1/5 one hypotenuse represents 1/5 of the total string. One hypotenuse is 30 centimeters, so there's a total of 150 centimeters of string wrapped around the thing. So anyway, thanks for watching. Have a good day.